crossroads, we call it, at the crossroads of energy and climate policies. And how I understand that is the intersection of two really pivotal historical, that we are at a very pivotal historical point, which, and this may sound like a way too sweeping generalization, but actually at a historical point that all of human history has never been at. And that would be, in terms of climate policy, the choice by the wealthiest countries in the world for less energy, for energy regression. And that's a very, very, very pivotal moment. What are the two forces that are going on? We have the unbelievable energy abundance that has been released very recently by the work of a lot of the people in this room. If one can, without all the necessary qualifications, attribute the refinements in hydraulic fracturing to a single individual, and of course it's never a single individual, but to George Mitchell, the son of penniless Greek immigrants that came to this country, who worked his way through Texas A&M tailoring that made possible, in conjunction with all kinds of other work, something that many had thought would not be possible. We have and are seeing the continual surge in this state and in this country, but also that is perhaps possible across the world. We have that opportunity and a look at human history, particularly from not so long ago. The Industrial Revolution to now is really the history of man's harnessing, diversifying his energy sources. So we have that incredibly positive, as Brooke said, optimistic moment in history. But we have, at the same intersection, federal policies which would not merely sanction or supplant, but eliminate the use of coal, natural gas, or petroleum. And if you think that's still a part of the future, that's something the government might do, EPA regulations now proposed, in fact, would use the coercive power of our government to eliminate coal. The talk about the Beyond Natural Gas campaign to follow the Beyond Coal campaign, again, is not rhetoric, but is real. And petroleum, the same rule that EPA has now proposed for existing power plants in the United States, they have committed to proposing for all refineries as their next version. It's quite real, and I say that from the standpoint of a past environmental regulator, that the actions this country has taken, this last rule that EPA calls the Clean Power Plan, is the most aggressive action on CO2 of any country in the world, because it is under the Federal Clean Air Act, which requires very detailed enforceability, verifiability. It is not an aspirational goal. These are two very, very inimical forces: our energy abundance and the opportunities that gives to us, as well as the use of the kind of power of government that could prevent taking advantage of those opportunities. Having for about the last 30 years dealt with environmental regulations and environmental law in very detailed, technical, analytical matter, the emergence of this crossroads really motivated me to take a very different approach to it. And I wrote a paper called The Moral Case for Fossil Fuels, which has been out there on the tables, but it certainly is the moral case for fossil fuels, for what the use of that energy that at this point in time we do not have a comparable substitute for, what the use and diversification of that energy has done for humanity is amazing. And there are plenty of very significant academic studies which trace that history from the not so long ago Industrial Revolution, when the average lifespan for all of humanity, for all time, was 25 to 30 years old. 30% of children died before they were 15. Since the Industrial Revolution and the prosperity that abundant, versatile energy and human innovation made possible, lifespan has tripled. Income per capita on a global basis is 11-fold higher. If those are not improvements and goods to protect, I don't know what would be. The prosperity and the productivity that a fossil fuel-based economy in a free society made possible has really been obviously of most value for a limited number of countries. But it has stretched throughout the whole world. The United Nations says that in the last 50 years, more people were released from poverty than in the last 500. The doomsday predictions of the likes of Paul Ehrlich and Lester Brown that said that the human population would so outstrip the food production capacity of the planet, none of those came true. And any number of agronomical studies find that 40 to 60% of that increased productivity, long thought impossible, was a result of a fertilizer based on natural gas. I won't go into other things, but the story of this, the real role of energy in our lives, and not just any energy. There's nothing special about fossil fuels, except it's the best. At this point in time, I would submit there is nothing superior and nothing available. So the risk that our country, and already countries like Germany and the UK are taking on renewable fuels is the first energy regression that I think we've seen since the Industrial Revolution. My book was in part inspired by an incredibly spirited book called The Rational Optimist by Matt Ridley, whom we're about to hear from. I would think particularly this week in the United States, there's very grim news that surrounds us on all sides, kind of demoralizing. And not just the international geopolitical, but economic and all of that. But if you reflect on the magnitude of improvement in basic measures of human being, health, lifespan, income, what the West has accomplished is unbelievably inspiring. And if looked at in a certain view, there's no reason why it can't continue unless government prevents that. I want to tell you just a little bit about Matt, who we wanted to have in person. His schedule did not allow, but I've learned his wife is from Houston, and he comes here annually, so next time we will coordinate. Don't know whether you've ever read any of Matt Ridley's books. He has many, two others notable called The Genome, the Human Genome, and another one called The Red Bee. He's often referred to as a polymath, which is quite a compliment, in that somebody that can be a mastery in a dozen fields at one point, and mastery. And Matt Ridley, I think, is unquestionably that rare individual with a gift of writing that can add spirit and compelling quality to what otherwise might be some very obscure subjects. His books have sold over 1 million copies and translated into 30 languages and has won many literary prizes. He's educated at Oxford, and he is now a Viscount, which I had to check out in to Google exactly where did that put you in the, and that's a very, very high-level lord. So he is Lord Ridley. He also founded the International Center for Life in Northumberland in England, which is a fascinating center where there's actually original scientific research going on, as well as all kinds of public educational things. Very, very interesting institution. He now is a member of the House of Lords. I'm glad his mind will also be devoted to policy making. And he is a fellow of the Royal Society of Literature and the Academy of Medical Sciences, and an honorary member of the American Academy of Arts and Sciences. His editorials appear frequently in the Wall Street Journal. I believe there was one 2 weeks ago entitled Whatever Happened to Global Warming, which, if you haven't read, would be a useful accompaniment to this conference. But before I welcome Lord Ridley by means of high-powered internet, I want to read you a quote from his book, The Rational Optimist, which is not just about energy, but energy plays a central role, that was so inspiring to me, and it is what real optimism means, which is always a kind of faith, but what real optimism means. Lord Ridley notes, resources such as coal, I would add, oil and natural gas, are sufficiently abundant to allow an expansion of both economic activity and population to the point where they can generate sustainable wealth for all the people of the planet without hitting a ceiling. The blinding brightness of this still amazes me. We can build a civilization in which everybody lives the life of the Sun King, because everybody is served by and serves 1,000 servants, each of whose service is amplified by extraordinary amounts of animate energy. Lord Ridley, I hope you are hearing what I'm saying, and we welcome you to Houston.
Thank you very much, Kathleen, for that kind introduction. Can you hear me? And I hope you can all see me. Very, very nice to be with you. I'm really sorry I'm not there in person. I hope the lunch is good, and I hope you'll save a little bit of it for me when I'm next there. But thank you for that wonderful introduction, Kathleen. It's a great honor to join the conference remotely. And I want to start with a quote from Woody Allen. He once said that mankind stands at a crossroads. One path leads to despair and utter hopelessness, the other to total extinction. But let us pray we have the wisdom to make the right choice between these two paths. Well, all too often, that's how people talk about the future. And I was really depressed as a teenager to be told that the future of the world was bleak. The population explosion was unstoppable. A pollution crisis caused by all the chemicals we were putting into the environment was going to shorten my lifespan compared with my parents. The desert was advancing, the oil was running out, the acid rain was killing the forests. All sorts of horrible things were going to happen. My sperm counts were going to fall. To cap it all, civilization would come to a crashing halt when the Y2K computer bug brought computers to their knees in 1999. And of course, it hasn't been like that. There are horrible things in the world. There's Ukraine and Iraq and the Ebola virus at the moment. There will continue to be horrible things. But on the whole, the future is surprisingly bright based on the trajectory of the past and based on how we improve our living standards as human beings. So I wanted to start by just taking you through some examples of that. And I hope that at this point you can see my slides. The first point is that what I want to do is to try and give you an idea of how much better off you are than your parents and your grandparents. Are you better off than they were 30 or 40 or 50 years ago? Well, that's what's happened to world economic GDP per capita, corrected for inflation over the last 400 years. It's an extraordinary hockey stick, and nearly all of it has happened in the last 50 years. The enormous increase, which Kathleen referred to, in the income, the amount of goods and services that a person can acquire in his lifetime or in a given amount of time. And it's, it continues that today, the last 50 years have seen world GDP growth continue upwards. Sorry, slide's not quite working. At the same sort of pace, and we've seen a dip in 2009. That's the only year since the Second World War when the world economy shrank. And it's back on trajectory now. It motors upwards. And where's it? And what might happen to it? Well, I'll come back to that later. And it's not just that the rich are getting richer, the poor are getting less poor. When I was born, about 60%, about 2/3 of the world lived on less than $1.25 a day in today's money. Today, that's down to 20%, and there's every reason to think that that number could go to zero in the next few years. And of course, $1.25 a day is still a ridiculously low level of income, but it would be wonderful to get that number down to zero, and there's every reason to think that we can. So we're better off. But are we healthier, happier, safer, better fed, cleverer, cleaner, kinder, freer, more peaceful, and more equal? And the answer to those questions is yes. Child mortality, the biggest measure of misery anybody can think of, plummeting all over the world, down by 2/3 in my lifetime. Sub-Saharan Africa lagged behind the rest of the pack for a while, largely because of the AIDS epidemic, but it's now catching up. Oh, sorry, I'm having a little trouble with my slides here. We're happier because there used to be thought that as people got richer, they got less happy. But it's not true. It turns out that between countries and within individual lifetimes, the people get happier as they get richer. Now, it's perfectly possible to be very rich and very unhappy. But of course, that's fine because it cheers everybody else up. Now, we're safer. Your probability of being killed by a drought, flood, or storm, which is what you can see on this chart, is down by 98% since the 1920s. That's not because weather got less dangerous. That's because we've got better communication, better infrastructure, better transport, all these different things that we need to improve our lifestyles. We're better fed. People have more food available per head on all the continents than they used to do. We're cleverer. We're better educated. More of us are literate. Literacy is approaching 100% in most countries. But not only that, IQ scores are improving even for the measures of IQ that have least to do with education. And that's because of better nutrition, better stimulation in childhood, and so on. So don't let anyone tell you that your grandparents were cleverer than you. It's not true. The world is cleaner, the air is cleaner in most parts of the world. I live in a part of the world where there's a river which now has salmon and otters in it, which did not when I was young, because of the clean-up of that river. This isn't happening everywhere. Some cities have dirtier air than before, but most are seeing steady improvements. This is from London and England. We're kinder. Your probability of being a victim of domestic violence is actually going down, particularly if you're a female. Not going down much if you're a male, but that's a mystery. We won't go into that. People are giving more to charity as a proportion of their income all the time. So the idea that we're getting nastier as we get richer just isn't true. And more of us are living under democracies than ever before. More of us are in free societies and fewer of us are in autocracies. We're more peaceful. The decade just ended was the one with the lowest number of deaths in warfare since records began. Now, it could be that the current decade is going to be higher than that. There's an awful lot of wars going on at the moment. But at least the trend has been in an improving direction. The surprising one, I think, is that the world is getting more equal. In 1970, a lot of people were poor and a few people were rich. Today, most people are in the middle. And that, of course, is because people in poor countries have been getting rich faster than people in rich countries have been getting rich. The GDP per capita of Mozambique is 60% higher today than it was at the beginning of the Great Recession in 2008. The GDP per capita of Italy is 6% lower. And that's as it should be, that a poor country is getting rich faster than a rich country is getting rich. So how is this possible? What is it that happens to human beings that enables this to happen? What is it about us that enables us to see improving living standards? Why does it happen to human beings and not to rabbits or rocks? And that's a question that I began to ask myself a few years ago. And I came up with the answer that it's to do with the way we interact with each other. This object sits on my desk at home. It's an Ashwalian hand axe of the kind made by Homo erectus 500,000 years ago. My wife got it for me on eBay. And right next to it sits an object of exactly the same size and shape. And I was very struck one day by the similarity between these objects. And if you think about it, this is kind of the whole history of humanity in these two objects. And there's a fascinating difference between them. The one on the left is made from a single substance, and the one on the right is made from lots of different substances, plastic and metal and silicon and all these different substances, but it embodies different ideas. The idea of computing, the idea of the mouse, the idea of communication. And of course, these ideas occurred to different people in different times and different places, and they came together in this technology. And I think that's what we do with our technologies and with our society, is we bring together ideas and combine them and recombine them. Every technology you think about, when you think about it, is combined of different ideas and different technologies. And the remarkable thing about that computer mouse is that it was made for me by other people, by hundreds, thousands, perhaps even millions of other people. Because there was a man working on a coffee farm in Brazil who was growing coffee for a man on an oil rig whose oil was going to be used in a plastic factory, whose plastic was going to be used to make the mouse, and they were working for me, making that mouse. They didn't know it, and I didn't know it, but that was what was going on. Thousands of people contributed to the making of that single object. And the even more remarkable thing about it, I think, is that not one of them knew how to make a computer mouse. Nobody on the planet knows how to make a computer mouse. The man who runs the computer mouse company just knows how to run a company. The man on the assembly line doesn't know how to drill an oil well, and so on. The knowledge that makes society work is not stored in individual heads. It's stored between brains. It's stored in a distributed way. We each know a little bit of the picture, and collectively we know all of it. So that's a picture of the internet, but it's also a picture of a brain. And as that brain gets more and more better connected, there's every reason to think that we will see improvements in our living standards, in our ability to cope with whatever nature throws at us. But of course, none of that would be possible without energy. And it's no coincidence that the amount of energy consumed in the world went up dramatically at the same time that living standards began to go up. And it went up fastest in the countries that grew fastest. Energy amplifies work. Energy enables one person to serve hundreds of other people instead of just a few other people. And that's what makes it such an extraordinary thing. And it's this explosion in the availability of energy that is really right at the heart of the great improvement. Well, can it go on? Or am I like the man who falls out of a skyscraper and says as he passes the second story, so far, so good? I don't think so. I think the ecological limits on what we can achieve are not nearly as severe as many people think. And in fact, there is every likelihood that this progress in human living standards can continue into the future. And I'm going to give you some ideas as to why I think that. The first thing to say is that population has been increasing, but at a slower and slower rate. Before I say that, I just want to give you this quotation. We cannot absolutely prove that those are in error who say society has reached a turning point, that we have seen our best days. But so said all who came before us, and with just as much apparent reason. On what principle is it that with nothing but improvement behind us, we're to expect nothing but deterioration before us? Well, that wasn't me or some other crazy optimist like me today who was saying that. That was the historian Thomas Babington Macaulay speaking in 1830, writing in 1830. And he was already fed up then with the green pessimists saying that life couldn't get better, that we had reached a turning point, that life was about to get worse. And yet, living standards had hardly started to rise even in Britain, let alone anywhere else in the world at the time. So we've been saying that this experiment is going to come to an end for a very long time, and we've been wrong about that for a very long time. So it would be odd if this generation was the one that happened to be the one that stood at a turning point in history. As I said, population is still growing, but at a slower and slower rate. In my lifetime, the population growth rate of the world has approximately halved, from 2% a year to roughly 1% a year. And that means that the world population quadrupled in the 20th century. It's not even going to double in the 21st century. And according to the UN projections, and they might be wrong, it's going to come down to the point where the population will stabilize sometime in the second half of this century. So coping with the world population is actually, in many ways, getting easier, not harder. What about the devastation of the environment? Well, here's a chart from Willis Eschenbach showing the total number of extinctions of bird and mammal species. And we're living through a period when we, human beings, have wiped out a lot of species. But it's not necessarily getting worse. In fact, if you look at that chart, you see that this extinction rate peaked in the late 19th century. In many ways, we're actually getting on top of this problem. And if you go back and look at what some people said in the 1970s and 1980s about the extinction crisis, it is remarkable how different they are from what has actually turned out. So, for example, Dylan Ripley said that 75 to 80% of species would be gone by 1995. Paul and Anne Ehrlich said 50% would be gone by 2005. Thomas Lovejoy said 15 to 20% by 2000, a much more modest estimate. Well, which of them was right? Well, the actual number for birds and mammals is that 1.3% of mammals and 1.4% of birds have gone extinct in 500 years. That's all. So although it is a problem, and it is an urgent and important point that we need to try and prevent the extinction of mammals and bird species, it is wrong to try and exaggerate just how bad this problem is. Indeed, in the Arctic and the Antarctic, we've seen a huge rebound in the number of whales and seals and penguins in recent decades. Why? Because these species were a source of energy. Essentially, we went after these creatures for hundreds of years because we wanted the oil, the blubber, the meat from these creatures, and the furs, of course, as well. And the fact that we now have fossil fuels instead means that we don't have to go and kill these creatures. So as somebody once joked, there should be a photograph of John D. Rockefeller in the offices of Greenpeace because he saved the whale. The most striking graph I think I've come across in recent years is this one, which was first shown to me by Jesse Orzabel of Rockefeller University. And what it shows is the decrease in the amount of land globally that we need to produce a given amount of food. So if you take all the crops in the world and you average what's happening to them, depending on how big a crop it is and so on, you come up with something called a crop production index, and we're using 68% less land to produce the same amount of food as we did 50 years ago. Now that is possible because of fertilizer. As Kathleen said, the availability of nitrogen fertilizer so that we can increase the yield of each acre means that we need fewer acres. And of course that spares land. This is causing land sparing on an enormous scale. This means that we've got room. If we'd continued to have the low yields of the 1950s today to try and feed 7 billion people, we'd need every square inch of the earth pretty well that could be cultivated. Whereas in fact, we can now spare land for nature reserves, for national parks, for golf courses, for residential property, or for just nothing if we want. And that to me is the biggest benefit that has come for conservation of wild creatures ever, and it has come from the use of fertilizer made with natural gas from the air. It's worth reflecting on just how far human beings have gone in expropriating the bounty of nature, if you like. At the moment, and this is a very careful calculation by Helmut Habel at Klagenfurt University, he's gone through the whole world, acre by acre, trying to work out what happens to the green vegetation in every acre. And he concludes that about 3/4 of it is still available for natural creatures to consume. We consume about 14% and we destroy or prevent from growing about another 9%. When I say we, I mean human beings and their domestic animals. So there's still 3/4 of the green leaves on the planet are being eaten by insects and deer and monkeys and things like that rather than by people or their domesticated animals. What would happen if we went back to using bioenergy, went back to relying on wood and these kind of things? Here's a picture of the Haitian-Dominican Republican border. And what this is showing is a brown country on the left, that's Haiti, and a green country on the right, that's the Dominican Republic. Why? Because Haiti relies on charcoal, on wood, essentially, for most of its fuel. Not just domestic fuel, but for industrial fuel as well. And as a result, it is largely deforested. Whereas the Dominican Republic uses fossil fuels. In particular, it subsidizes the use of propane as a cooking fuel specifically so that people will not go into the forest and cut down trees. And so that's a picture of what the world would look like if we all went back to nature. Nature would not enjoy the fact that we all went back to nature. It's worth reminding ourselves that one of the biggest killers in the world is indoor air pollution. And by that I mean the smoke from open wood fires in people's homes. And in large parts of the world, particularly Africa, but also India, many people are dying from this cause. And that's because they lack access to electricity, to kerosene, to all the other things that other people have that enable them to cook without burning smoke in their homes. So if we're talking about real problems in the world, this is one that should be high on our list of priorities. You can see in the chart of our fuel mix over the last 200 years just how the displacement of wood from what we relied upon for our energy by, first of all, coal, then oil, increasingly natural gas, and to some extent nuclear and hydro, has been the story of the Industrial Revolution. And the Industrial Revolution would not have been possible without the addition of these fossil fuels. We're in a fascinating situation today, as Kathleen mentioned, with the extraordinary abundance of natural gas in the United States, thanks to the shale gas revolution, which began in the Barnett Shale in Texas a few years ago. And it's a very worrying thing for us in Europe, because here is America now producing gas far more cheaply than Europe or Asia. Whereas up until 5 years ago, gas prices were comparable in the three continents. Now America has an enormous competitive advantage. And as a result, there is reshoring of manufacturing industry to North America and chemical industry. And it is absolutely vital that Europe follows America down this route and exploits its abundant shale gas reserves if it is to regain a competitive advantage in many of these industries. Well, what about the really big constraint on growth that most people talk about, the one that most people are interested in, and that is that we're increasing the amount of carbon dioxide in the air by burning fossil fuels. And it's true, we have increased the amount of carbon dioxide in the air, and almost certainly this is due to the burning of fossil fuels. It's gone from 0.03% of the atmosphere to 0.04% of the atmosphere, which isn't a very big change in terms of the composition of the atmosphere, but it is a big change in terms of the amount of carbon dioxide that is there. And that's supposed to have warmed up the Earth. And it probably has. The climate change as a consequence of the greenhouse effect of extra carbon dioxide is probably real. But it is not a rapid change, and it is not accelerating. If you take the last 35 years, which is roughly the satellite record, and if you look at both of the satellite temperature data sets plus all three of the surface data sets, and you average them, then you get this line, this black line, which shows an increase that kind of levels off in the last 15 or 20 years, and that in total means that we're about 1/3 of a degree warmer after about 1/3 of a century. So we're going at the rate of about a degree per century, which is much slower than forecast by the models. And it's not even actually that impressive if you look at it on another scale. This is exactly the same graph, but it shows the actual temperature as opposed to the temperature anomaly. Basically, we've gone from about 14¼ to about 14¾ of a degree over the last century. So it isn't that big a change as far as the planet is concerned. Indeed, if you look at it by latitude, the warming has happened mostly in the Northern Hemisphere. The blue line in this is the temperature of the Earth by latitude in the 1980s. The red line is the temperature of the Earth in the last decade. And as you can see in the Southern Hemisphere, there's just no difference between them. It's impossible to pick up this warming on this scale because the difference between different regions is so much greater than the difference between different times. You can see it more clearly in the Northern Hemisphere, but it's not a big change compared with the variation there is between different regions of the Earth. Now, this warming has happened, but it has happened slower than forecast by the models on which the Intergovernmental Panel on Climate Change relies. Here's one of the surface temperature records and one of the satellite temperature records lagging further and further behind the runs of the different models shown here. So 87 of the 90 models are forecasting that we should have had higher temperatures by now than we have had. Well, the warming may be happening to the sea instead of the air. That's the latest idea, is that a lot of this heat is going into the ocean. Well, this is Willis-Eschenbach's chart showing the ocean temperature anomaly for the top 700 meters of the ocean. And yes, it has increased, but it's not accelerating. In fact, it looks like it's decelerated in recent years. And notice the axis, notice the measurement. This is in hundredths of a degree. So it's a tiny change in terms of ocean temperature, and this is based on some buoys that go down to about 700 meters, take the temperature and then bob up and transmit their data back, and they're supposed to be taking the temperature of the entire Pacific Ocean, the entire global ocean, to within hundredths of a degree. You've got to be pretty sure that you're getting it right to be sure that this is a real trend and not an artifact. Certainly, we have seen a retreat of Arctic sea ice in summer, not in winter, but in summer, over the last 30 years. And it's a pretty steady retreat when you look at it like that. But the puzzling thing is that we've seen an increase in Antarctic sea ice over the same time. Indeed, Antarctic sea ice is currently breaking all-time records for the satellite era every day pretty well as we speak at the moment, because, of course, it is close to the maximum sea ice in Antarctica at this time of the year. So that was not forecast. In fact, the 2007 IPCC report still specifically forecast that there would be a decrease in Antarctic sea ice. Instead, there's been an increase. Now, some people have explanations for that, but it is nonetheless a puzzle. We are warmer today than we were a couple of hundred years ago. There's no doubt about that. But the evidence suggests that we are cooler than we were 1,000 years ago. These are 18 non-tree ring proxies and one on the right, which is the polar Ural tree line, which shows a warmer period in the Middle Ages. And if you take the really long view and you go back 8,000 years, there is no question that the world was much warmer in what's known as the Holocene optimum. This is data from Greenland, but it's similar from other parts of the world. It was warmer 8,000 years ago considerably. Every 1,000 years since then has been cooler than the one before. That's what that step black chart shows. And this is what we would expect, because the power of the sun in the northern hemisphere in July has been getting less. That's what the red line shows. And that is the determinant of whether you come out of an interglacial and go back into an ice age. So there is the very, very, very slow, very gradual and very erratic progression towards an ice age that we should be expecting. Well, what's the impact of all this so far? I mean, are we suffering badly as a result of this burst of probably man-made warming that we've seen in the last 30 or 40 years? On the whole, not. The amount of the world that is, the fraction of the Earth that is in drought is not increasing. In fact, it's ever so slightly decreasing. This is a paper from Nature just a few months ago that's very carefully measured how much of the world is in drought at any one time. There is no increase in drought. The level of the sea is rising, but it is not accelerating. It's going up at the rate of about 3 millimeters a year. That's about a foot per century, which is not much more than it was in the 20th century, and we coped with that. Greenland is losing ice at the rate of about several gigatons a year, which sounds a lot, billions of tons a year. But actually, it's 0.5% per century. That means that in 100 years, Greenland will be 99% intact. Glaciers are retreating all around the world, but they've been retreating since 1850. And nobody thinks that the first 2/3 of that retreat was caused by man-made global warming. It was probably a natural phenomenon. So there's been no acceleration in the retreat of glaciers. It looks like they're retreating because that very cold spell around 1700, which was known as the Little Ice Age, has come to an end. There is no increase in the amount of, in the frequency of cyclones hitting land anywhere in the tropics, strong ones or weak ones. There is no trend in this data. There is no decrease in the amount of winter snowfall. The IPCC had a chart showing a decrease in snowfall, but it measured only March. It was careful not to measure. If you look at the whole of winter, which is what this is, there has been no change. In the UK, we have been led to believe that we've had bursts of particularly heavy rainfall as a result of climate change. Not true. This is the data. The amount of rainfall per day when it rained in the UK, and boy does it rain in the UK, the amount of rainfall has not changed per rain day. And the Intergovernmental Panel on Climate Change itself says that there is no increase in extreme weather. Here's a quote from its report on the subject in 2012. Uncertainty in the sign, that is to say whether it's positive or negative, of projected changes in climate extremes over the coming 2 to 3 decades is relatively large because climate change signals are expected to be relatively small compared to natural climate variability. Or to put it another way, as you know only too well in North America, you can have a very cold winter in a warming world. One of the centerpieces of the predictions of climate change in the 1990s was that it would cause a huge worsening of malaria because it would make the world warmer and more congenial to mosquitoes. But actually what's happened is that malaria retreated dramatically in the 20th century despite a warming of the world. Why? Because we combated malaria. And it's mad to think that the way to combat malaria is to change the temperature of the planet. The way to combat malaria is to tackle malaria. And there's every reason to think we're going to go on doing so. Malaria mortality is down by 25% in this century alone. Well, the aspect of this that I find most intriguing and most surprising is that the planet is getting greener. And I mean that quite literally. Here's a study by Randall Donoghue of the CSIRO in Australia, which showed that in many parts of the world, there has been an increase in the amount of green vegetation over 30 years, and this is measured by satellites. And here's another by Rangamai of Boston University finding much the same thing. Again, with satellite data, a trend, the gross productivity of the vegetation has been going up. And what Maineni finds is that there has been a 14% increase in the amount of green vegetation on the planet, and that it has happened in all ecosystems, not just in farmland, but in rainforests and semi-deserts and other areas too. What's the explanation? Well, both Maineni and Donoghue and others think that a large part of the explanation is the CO2 fertilisation effect. That is to say, if you put more CO2 in the air, plants grow faster, and they're able to grow in drier conditions because they don't have to open the pores in their leaves so much to get hold of CO2, and therefore they don't lose so much water. Greenhouse owners know this. They pump CO2, commercial greenhouses pump CO2 into greenhouses to accelerate the growth rate of plants. And as you can see, a plant grows much faster at 750 parts per million of CO2 than it does at 200. So if you measure the effect of this CO2 fertilisation effect on crops, it comes out, according to Craig Itso's calculations, that we may be seeing about $140 billion worth of benefit every year simply from the fact that there's extra CO2 in the air. Now, this is not a very fashionable conclusion to reach, to put it mildly. But we're fighting climate change, and we're doing so by going towards renewable energy and trying to reduce the amount of CO2 we produce. And in doing so, we are causing real suffering. And I want to pose the question whether or not that suffering is worth it. Whether or not it's possible that if the disease is really quite mild and indeed has some benefits, should we really be taking painful cures for it? I mean, here's one. Induga Klani has calculated very carefully and very cautiously that biofuels may be killing 200,000 people a year. That is to say, by taking land out of producing food and putting it over to producing motor fuel, and in the world as a whole, we took 5% of the world's grain crop last year and turned it into motor fuel, which displaced just 0.6% of the world's oil use, so it had very little impact on oil use, but it had a huge impact on food prices, and that, of course, tipped people in many poor countries into malnutrition and therefore killed many people. And that's a calculation you cannot get away from, that green energy has a death toll. Likewise, we are, in my country, covering as many of the beautiful views that we've got in the north of England as possible with these enormous crucifixes to try and change the climate. And do the calculations. Try and see whether or not this would actually make a difference. If we were to prevent CO2 emissions rising, and this is based on an optimistic calculation of how much CO2 a wind turbine actually saves, if we were just to prevent world emissions rising, let alone cut them, we would need to build a new wind farm the size of Germany every year. It's not going to happen. And yet we're spoiling enormous areas of the environment to do this and killing lots of golden eagles into the bargain. Meanwhile, one country has managed to cut its carbon dioxide emissions much faster than all other countries, and it's the United States. And it's done so by substituting gas for coal in electricity production as a result of the collapse in the price of gas thanks to the shale gas revolution. So this is the most effective anti-CO2 policy that has ever been found so far, is the displacement of coal by shale gas. Well, let me end with a really key point, which I think is absolutely crucial to this, and that is that the richer we become, the more we'll cut emissions. Now, is that just me saying wishful thinking? Well, no, actually, it's what the Intergovernmental Panel on Climate Change says. If you look at it carefully, here are two charts from the Intergovernmental Panel on Climate Change. This one shows the warming under two different scenarios, RCP 2.6 and RCP 8.5. RCP 2.6 produces almost no warming. The warming peters out, the temperature stabilizes, problem solved. RCP 8.5 is a nasty one where the temperature goes on roaring upwards and we're 4 degrees warmer by the end of the century than we are today. And this is based on estimates of sensitivity that we now know are too high, thanks to the work of Judith Curry and Nick Lewis, published just in the last couple of days. And I'm sure Judith will be talking about that more during the meeting. But it would be nice to avoid RCP 8.5, wouldn't it? And it would be nice to live in a world of RCP 2.6. Well, to get to that RCP 2.6, do we have to wear a hair shirt and go back to nature and give up our cars and give up our aeroplanes and all that kind of thing? No, because if you look at GDP, it goes up faster under RCP 2.6 than under any other scenario. And it goes up slower than almost any other scenario under 8.5. GDP per capita is 16 times as high in the year 2100 as it is today in real terms in the low temperature increase scenario. What this is saying is that the more we grow, the more we will innovate and the more we will solve the problem. And it's trade and innovation and technology that is going to produce the problem. Meanwhile, RCP 8.5, the dangerous one, has some truly ludicrous assumptions in it. It assumes that there will be 12 billion people on the planet in 2100, which is probably a billion too high. It assumes there will be very little trade going on, so every country is reliant on its own resources. It assumes that 50% of global primary energy will come from coal, that we'll be using 10 times as much coal as today. Nobody I know thinks that. And it assumes that the sensitivity of the atmosphere to carbon dioxide is twice what it was. So, to summarize, I think, let me just set out the climate change proposition that we hear, that carbon dioxide levels are rising, that carbon dioxide is a greenhouse gas, that the climate has been warming, that the planet is getting greener, that global warming, that nonetheless may be fast and dangerous, and that renewable energy is cheap and safe. Well, I agree with all of that, except that I don't think there's any evidence that global warming is fast and dangerous. I think there's lots of evidence that it's slow and mild, and I think there's lots of evidence that renewable energy is expensive and damaging. And so, to put it bluntly, I fear that we are taking chemotherapy for a cold. Thank you very much for listening to me. I hope you could hear me. I look forward very much to taking a couple of questions from you if it proves to be possible.
Thank you, Lord Ridley. I wish you had been speaking to the climate summit in the United Nations earlier this week. They needed your presentation. We are going to have to only be able to take one question, so I don't know who the lucky, because we need to get back on our schedule. But be brave, raise a hand.
I talked too long.
But so not. Do we have a question here? No, we have someone leaving. Yeah. Yes. Steve Moore, please. Here,
okay. Thank you for the great presentation. I just wanted to ask you a question about, a lot of these models with respect to things like climate change. Even the data that you presented with satellite data and so on goes back maybe 30, 50 years, which in the course of human history is an eye blink, right? And I just wonder if you think that one of the problems with a lot of these apocalyptic predictions is looking at extremely short-term trends and projecting them out. If you look at longer-term trends, they sort of flatten out. And I wonder if that's part of the problem of this kind of alarmism of just looking at trends over 5, 10, 20, 25, 30 years, not looking at 500 years or 1,000 years.
I think you're spot on, Steve. I think that's a really important point. And there's a thing called the availability heuristic, which is the rule of thumb whereby we're really influenced by what's just happened, what's immediately available, what's immediately obvious to us, and we tend to forget about this. So, for example, the Arctic sea ice. We know it's been retreating since 1979 when we first started getting satellite data on the extent of it. But we also know, not from satellites, but from other data, that actually the 70s was an era when the Arctic sea ice was probably at quite a high level compared with previous decades. Indeed, we know from the 1920s and 1930s there are all sorts of reports from people in the Arctic saying that the Arctic sea ice had retreated a great deal. So we just can't be sure that the decrease we're seeing at the moment in the Arctic sea ice is for real. I'm sorry, it's certainly for real, but it is man-made, as opposed to being something that might have happened before.
Well, we have one more? Yes, please.
Yeah, some years ago, I read an article that there were two schools of thought with regard to the fossil fuel concept, okay? One was the Western idea, which was fossil fuel, and another was that it was a natural process of the Earth. Now, some years ago, I think it was Anderson, when he headed Atlantic Richfield, that said that they were not fossil fuels, but a natural process of the Earth. And now we have, or some years ago, we have the biogenics theory, which is different than its fossil fuels. And as we get deeper, and some of the stuff you see more and more referring to the source rock. And so I'd appreciate if you'd comment on that a little bit.
That's a really interesting idea, and it's one I've explored a little bit. So the question is all the gas and oil that we find in the rocks, is it made from rotting animals and plants, or is some of it methane that existed in the Earth when it was formed? And the answer is we don't know. We've only ever used the biogenic stuff that we think, as far as we can tell. We're not sure yet whether we've got hold of any of the other stuff. Tommy Gold had the theory that if you drilled deep enough into granite, you would find a biogenic methane down there left over. And given that there are lakes of liquid methane on one of the moons of either Jupiter or Saturn, I can't remember which, given that we know that there's tons of methane in a lot of heavenly bodies, yes, it's likely that the Earth had a lot of methane in it when it was formed, and some of it will still be down there. Whether we can ever find that and whether it's significant, we're not sure. But there's a third possibility, which is the Russians are particularly interested in this area, and they've come up with a third possibility, which is that all the carbonate rocks, all the chalk and limestone, etc., that forms on the bottom of the ocean, then gets sucked down into the mantle in the subduction zones around the edges of continents, and some of that gets reduced back to methane. But there's the conditions under which that carbonate could be turned back into hydrocarbon exists down at these in the mantle. So that would then bubble up again. And a lot of the enormous reserves of methane that we know exist around the continental margins in the oceans in the form of hydrated methane, clathrates, some of those, we're not quite sure where they came from. So I think it's a really interesting question, still an open one. And if we run out of the biogenic stuff, there might be an awful lot of abiogenic stuff deeper down.
Lord Ridley, thank you very, very much. I'm also pleased to say that,
Thank you.
I'm pleased to say we have copies of his books that can be purchased in the lobby at some point during the conference. But most of all to you, Sir Ridley, I hope the next time, as you proposed at the beginning of your speech, in Texas, we will be able to feed you. Thank you very much, sir. So we are a little behind time, so I believe it'd be a good idea to get right to the next room for the first panel of the conference, which will consider the science and the brilliant paper that Lord Ridley mentioned that Dr. Judith Curry had written may be referenced by Dr. Curry herself at this next panel. Thank you all very much.